Hi, my name is Ed and today we'll try to find out if mining kills. For this series I've received Gigabyte 1070 which was bought by my friend back in 2017. And I've been used in mining rig for almost 5 years non-stop in very rough conditions like rooms with only 20 degrees in summer and around 20 degrees in winter. So it was used to mine Zcash and Bitcoin Gold for around a year, which is very GPU intensive algorithms, and around 4 years it was mining Ethereum, which mainly stressing the VRAM. So let's open the box and see what we got inside. As I asked my friend to send the card as it is, just pulling out of the rig without any cleaning or dusting. Once a year all the GPUs in the ring have been cleaned by the compressed air, and that's it. No thermal paste was replaced, no thermal pads was renewed. Everything is factory, as you can see the oil stains from the thermal pads on the backplate all over there. So today we'll clean all this up, we'll remove the old thermal paste, we'll install the new ones, also then we'll apply the new thermal paste and we'll see what's the difference we'll get. And if mining card still can work and play games after 5 years of stressful usage. As you can see all the dust which is accumulated during this last 1 year after the cleaning. So now let's take it apart and see what's inside. For this we'll remove all 4 screws holding the radiators and the screws holding the black plate, and we'll try to detach the cables for the fans and LED lights. And here we can see the GPU die with the VRAM. So this is the whole thermal pads. They are in pretty good condition even though they were working 5 years non-stop. As you can see the card is pretty good conditions, not taking into account the old thermal paste which was dried out, and going forward it was very difficult to remove. So I used the alcohol to clean the old thermal paste which was very dry. But thermal pads was in good condition. They were coming out in one piece, so nothing critical. And we can see the micron memories. So now let's remove the backplate. See what we got there. This is the thermal pads which was leaking, thick ones, which is covering the GPU die from the back. So let's remove the thermal pads. As you can see all thermal pads for the VRAM and memory modules coming in one piece, which means they are not dried out and still can pass some heat to the radiator. Even these tiny ones, which I guess 0.5 millimeters, is still coming out in one piece. So now let's remove the radiator from the fan and see what we have there. It's pretty dirty. There is a dust all over the place, which needs to be cleaned up. And now let's see which conditions are the fans, which is the factory fans, which have been used 5 years non-stop, and all have been done is just compressed air, which of course cannot clean the dust from the back of the fans. Now let's remove the fan from the case in order to be able to clean them up and to wash the case to have a nice looking shiny one. So after everything was taken apart, it was thoroughly cleaned. As you can see, the old thermal paste have been removed by using the alcohol. And now let's cut thermal pads by the size of the old ones and install them. Also, we need to replace the thermal pads or the power components of the board, which is very important. And by the way, I'm using the regular thermal pads and thermal paste, which I found on Amazon. Just nothing fancy ones, not the best ones in the market, to have a fair comparison, as I'm pretty much sure that none of GPU manufacturers are using the top quality thermal pads or thermal paste. So to have this comparison fair, I think we also have to use some mid-range thermal solutions. Which in this case, for the thermal paste, I'm using the Corsair XTM50, which is the average thermal paste, nothing extraordinary, so it should provide pretty good comparison with the factory thermal paste. Now let's connect the fans, LED lights. Before taking apart, I also tested the GPU in the test bench as it is, with to see what numbers we will get, and then to compare that numbers to the cleaned and repasted GPU. So this is what we got. Clean fans, clean radiators. It's like a brand new. So this one is the old one, which I'm installing in the test bench to see what temperatures we'll get after the testing, to compare to the clean GPU and see what's the difference. So let's power on the machine and start the testing. For the testing, I will be using the formark on 1080p with 8x anti-aliasing to stress that GPU. So you can see the factory overclock, nothing is touched, the fans on auto, and we'll run it for 9-10 minutes to see what the temperatures will be at the end and what the fan speeds will be at the end. Also, to see the hotspot, I will run the hardware info 64 and we'll see what's the difference between the GPU temperature and the hotspot temperature. So the GPU is getting warm, it's already 64 degrees. And the hotspot, we can see that it's on 76 degree, which is roughly 10 degree difference, which is quite normal. So it's like 10-11 degree difference. We're using 170 watts and GPU utilization on 100%. You can see also the board has higher power limit than the Founders Edition, so it's using around like 84-85% of the board power limit. So 175 watts, we're already reaching 67 on the GPU and 78 on the hotspot. Let's see what we'll get at the end by 9-10 minutes. So it seems the temperature are stabilized, it's not going up. You can see that also by the straight line formark, and we are just using 54% of our fan speeds. So now let's install the cleaned up version of the same card. Let's see what will be the difference after applying thermal paste and new thermal pads. Same 1080p with 8x anti-aliasing, and let's start the testing. Also we can see no artifacts, nothing, it's running pretty smooth. Let's see what's the temperatures on the core hotspot. So on the core we can see that the fans even not started yet, and the core temperature is 48, but it's going up. And soon the fans will start. The 53 degree and the fan started. So we have 30% fan speed and 55 degree on the core. Let's run it again 9-10 minutes and see what temperatures we'll have. So we can see that we on 62 degree, and again the hotspot difference is 10-11 degree, and we're running around 73 degree. So let's see, after the 9-10 minutes of foremark, our temperatures are stabilized and they are 62 degrees, which is 5 degrees cooler, with fresh thermal paste and thermal pads. And you can see it's straight line, and the fan speed is 48, which was 54 before. I went further and keep PC running for another 3 hours with side panel closed to simulate real gaming session, to see what the temperatures will be, and also if we will get any artifacts from GPU die or memory. As you can see, there is no artifacts. The fan speed in 51, GPU utilization 100%, power limit utilization 80%, maximum temperatures 64, and the fan speed just 51%. So all this in the closed case running 3 hours. And this is the results for 10 minutes foremark run before and after. We can see that after the fresh thermal paste we shaved 4 degree and we shaved 6% of fan speed, which is quite noticeable. This part of voiceover is recording after 3 months of heavy usage, where I was testing these cards in games, in rendering applications, and I didn't notice any issues with the card. The card is running perfectly fine, as it was like brand new. So what I can say, if the card was built from the factory on quality components and with quality cooling, including the cooling of the components, it can survive the mining even after 5 years heavy usage. So when buying a card from used market and you don't know about the history of card, pay attention on the quality of that card. If it's good quality card, you have to worry less. Mining can damage the card, of course, but the higher the quality of the cards, the less damage it will get. And as you can see on this example, I cannot see any damage on the card, and it can play any games which it's designed to play. Thank you, and see you in the next one.